There's a part of the ocean where even the most advanced warships on Earth secretly fight their dirtiest battle. Not against enemy submarines or missiles, but against their own trash. We talking about literal mountains of garbage floating inside one of the most disciplined ecosystems humanity has ever built, the modern aircraft carrier. Every day, 5,000 sailors eat, sleep, shave, cook, work, and fight inside what is essentially a steel city floating on saltwater. Now, imagine the amount of waste that generates. Plastic cups, oil rags, food scraps, medical waste, packaging, paper, batteries. It's endless. On a bad day, the waste can pile up faster than missiles on the flight deck. And here's the shocking part. Each carrier produces nearly 20,000 pounds of garbage daily. That's like a dozen pickup trucks of trash floating in the middle of the ocean. That is why in this video, we'll show you the extraordinary process through which aircraft carriers and their 5,000 sailors process, recycle, and dispose of mountains of waste. So, if you've ever dreamed of venturing into the sea this year, swim to that subscribe button. Part 1. The Floating City Problem. At first glance, an aircraft carrier looks like a fortress that forgot than 3 football fields, carrying more steel than some small towns. Jets roar off its back, sailors run in tight formation, and somewhere below, chefs are flipping thousands of eggs on hot pans. It's a city, one that floats, fights, and never sleeps. But beneath all that military precision lies an oddly human problem: garbage. An aircraft carrier can't just toss its garbage overboard. International law forbids it. Environmental ethics forbid it. And common sense, if you've ever been downwind of a decomposing food bag, definitely forbids it. Yet, the carrier is thousands of miles from shore, sailing across oceans that have no garbage trucks, no landfills, no city sanitation department waiting to haul the mess away. So the ship becomes a self-contained ecosystem, a mechanical stomach that must digest its own waste. Everything eaten, used, or discarded must be crushed, pulped, melted, incinerated, or stored. If you were to walk through the ship at dawn, you'd see sailors in narrow corridors pushing bins of pulped food, engineers monitoring compactors the size of refrigerators, and the faint, metallic smell of burned refuse lingering near the lower decks. It's not glamorous, but it's essential, because if the carrier fails to handle its waste, life on board quickly becomes unlivable. Smells, disease, and chaos would spread through the ship like contagion. So, how much waste are we really talking about? Enough to fill a small barge every week. Enough to make you rethink what clean means when you're surrounded by nothing but water. Stick around, because the next part will pull back the hatch and show you the true scale of this floating problem. Part 2. Measuring the mountain. Let's start with baseline. On a modern aircraft carrier with around 5,000 crew, estimates point to 8,000 to 9,000 kilograms of solid waste every single day. That's 17,600 to 20,000 pounds of trash, the equivalent in weight of 8 or 10 compact cars. A per-person estimate is about 1.36 kilograms per sailor per day, extrapolated from naval waste studies. Over a 20-day underway period when the ship doesn't pull into port, that waste tally swells to nearly 200 metric tons. Imagine 20 fully loaded dump trucks. All of that must be processed, stored, discharged if allowed, or incinerated. Now, waste is not uniform. The galley, the kitchens, mess halls, food prep spaces is the single biggest contributor. Naval studies show roughly 70% of all waste aboard comes from food and kitchen operations, and nearly 45% of the ship's plastic waste originates there. Meanwhile, about 60% of the total waste is actually food, wet organic. To put that in context, think of an entire floating restaurant district cooking 3 meals a day, tearing down packaging, tossing leftovers, all in closed quarters. The sheer volume of peeling, scraps, wrapping, cafeteria trays is mind-blowing. To move food waste from the galley to the waste processing room, carriers historically used plastic trash bags, but those bags themselves become waste. Studies aboard carriers found that just for food waste transport, a ship might use 285 pounds or 129 kilograms of plastic bag material daily. Over a 6-month deployment, those bags alone can amount to more than 25 tons. So the system is using waste to move waste. Fun fact, to break that loop, the Navy has solicited designs for reusable reusable container systems that can eliminate much of that bag waste, cutting costs, reducing plastic load, improving hygiene, but they're still testing prototypes. Plastic waste is especially troublesome. By one study, daily plastic waste aboard one carrier might reach 1,200 pounds, approximately 545 kilograms, nearly 8% of daily waste total. Those plastics can't legally be dumped, so they're shredded, melted, compressed into dense pucks, and stored until the port offload. On a historical note, in the early 2000s, sailors aboard USS Theodore Roosevelt were reported releasing bundles of garbage, including ground food, pulped paper, and human wastes daily into the Arabian Sea. They claimed 500-pound bundles, 8 per day, and over 400,000 gallons of human waste were said to be discharged too. This is a nightmare for the environmentalists. That practice is deeply curtailed today, but that glimpse reminds us the scale of waste has always been immense. The mountain isn't just solid rubbish. Ships generate black water, toilet waste, gray water, wash basins, showers, galleys, and bilge/oily water. Machinery room drainage. These liquids are volatile and regulated heavily. In the U.S. Navy, ships are outfitted with Type 3 marine sanitation devices, MSDs. These systems collect, hold, and sometimes treat black water while the ship is within restricted zones. Only when the ship is far enough from shore under regulations can certain treated effluents be discharged. Gray water may sometimes be discharged when permitted, but in many areas it must also be held or treated. The Navy is developing membrane treatment systems to reduce environmental impact. Bilge water is especially tricky because it may carry oil or fuel residue. The ship must separate oil and treat the water through oily water separators. Under MARPOL rules, only water below a certain oil threshold can ever be discharged. Some ships over history have infamously used magic pipes, clandestine bypasses that dump untreated oily water into the sea illegally. Those cases have landed ships and crews in court. Part 3. Rules of the Ocean. When you peer into the heart of naval operations, you realize one immutable truth. The ocean is not a free trash bin. For aircraft carriers, that unspoken reality becomes a daily constraint etched into every garbage decision. Beneath their decks, the rules of the ocean, laws, treaties, Navy instructions govern every wrapper, every food scrap, every drop of bilge. Ignore them, and the consequences can be diplomatic disasters, fines, or even criminal prosecution. The foundation is MARPOL 73/78, an international treaty born in response to decades of unchecked ocean dumping. Its Annex 5, dealing with garbage, is perhaps the most critical to naval waste operations. Under Annex 5, the discharge of plastics is absolutely banned in all waters, period. Only under tightly controlled circumstances may non-plastic waste be discharged, and then only after following strict distance, processing, and permission protocols. Every vessel over 100 gross tons or carrying more than 15 people must carry a garbage management plan and a garbage record book. These documents are not mere formality. They are legal instruments. Officials or inspectors can demand them at any time. Annex 5 was amended so that its prohibitions are stricter. As of January 2013, the assumption flipped. Before, some garbage was allowed under certain conditions. Now, discharge is prohibited unless explicitly allowed under very narrow rules. This means a carrier must prove that it qualifies for any discharge, not assume it can. Inside the U.S. Navy, these international rules are layered with further directives. Opnavenst 5090.1d sets environmental readiness policy. Every ship, afloat or ashore, must operate in compliance with federal, state, local, and host nation environmental laws. For carriers, that means synchronizing their internal waste handling with rules laid down by the Navy, by law, and by international treaty. On USS George H.W. Bush, the waste teams even call themselves raccoons because they dig into every crew member's trash to ensure compliance. Trash is not casual. It's audited. One of the most infamous blowbacks in naval/maritime history is the magic pipe scandal. A magic pipe is a clandestine bypass, a hose or system illegally installed to dump untreated bilge water or oily oily waste directly overboard, circumventing the ship's oily water separator and threatening both law and environment. Some of the worst penalties in modern maritime law stem from such hidden systems, combined with falsified record books. Ships have been brought to court because officers lied, destroyed evidence, or omitted entries in their garbage record book or oil record book. One cruise line company paid $40 million in criminal fines for deliberate vessel pollution and cover-ups. If those scandals seem distant from a military vessel, remember, naval ships are not immune. The rules apply everywhere, even in international waters. If the violation is traced back or discovered in port, legal consequences follow. What does all this tension look like inside a carrier? It means garbage teams must trace every disposal back to the regulation. Can this plastic be legally dumped? Number. Must we store it until port? Yes. Has this food waste been ground finer than 25 millimeters? Is the ship more than 3 nautical miles from land? Then maybe we can discharge. Every container, every pipe, every bin is a potential legal liability. Ships are often inspected by port state control, flag state auditors, or environmental agencies. A wrong move or a fudged record, and the carrier can lose credibility or pay huge penalties. Part 4. Machines of cleanliness. In the dim corridors below the flight deck, hidden from view yet utterly vital, a silent army of machines hums and whirs. This is where trash is not waste so much as raw material to be tamed. Onboard systems and equipment are the unsung heroes of a carrier's battle against entropy. Without them, the concept of living at sea for weeks would become a stinking nightmare. Every journey begins at the source. Around the ship, colored bins, receptacles, and containers marked for food scraps, paper, plastics, metal, glass, and hazardous waste await disposal. Sailors are trained in source separation, which on paper sounds trivial, but in practice can mean the difference between a compactor breakdown and smooth operation. Once mixed, waste becomes a monster, more dangerous, more costly, harder to treat. The first major step is pulping and grinding. Food waste and paper and cardboard, once separated, are fed into shipboard pulpers or grinders, which grind them into a slurry or fine slurry that can be pumped overboard under permitted conditions. Bones, pits, and non-pulverizable debris are often excluded. This step reduces volume and transforms solid chunks into more manageable form. One naval report states that carriers process tons of cardboard daily. In fact, one ship might generate 3,000 pounds of cardboard per day, and crew typically spend over 35 man-hours daily just breaking down boxes and stripping labels and tape before they even feed the waste into the pulper. Next, shredders take over. Metal, glass, and hard waste items, cans, bottles, scrap metal, are shredded into smaller bits so they can either be bagged and sunk or, if regulations allow, discharged under strict conditions. Older Navy plans envisioned vertical trash compactors, pulpers, and plastic processors. Over time, those plans evolved, and the compactor idea was dropped in favor of shredders and improved pulpers. Plastics present perhaps the greatest challenge. They don't decompose, float, and are strictly regulated. A clever system aboard many warships is the plastics waste processor. The typical sequence: shred, melt, compress, and form into solid discs, called pizzas or pucks, a few inches thick and many inches in diameter. These discs shrink the volume of plastic dramatically. Some claims suggest a 30-to-1 volume reduction. These plastic pucks are sealed and stored on board until the carrier can offload them at a port facility. Then there are compactors and balers. Where possible, non-hazardous waste is compacted to squeeze out air, reduce bulk, and make transport easier. That said, heavy compactor systems were once part of the Navy's vision, but were scaled back or canceled due to complexity and limited usefulness under ship constraints. Some carriers also use incinerators, especially for burnable items like textiles, untreated wood, paper, if not mixed with plastics, rags. Ash must then be handled as solid residue, but burning plastics at sea is controversial and often banned. Many naval directives prohibit incineration of plastics because of toxic emissions. Emerging technologies push things even further. Plasma arc thermal destruction is under research, using high-energy plasma to break down organic waste and plastics into syngas, slag, or inert materials. One proposed system for carrier scale might run at approximately 150 kilograms per hour, with 2 units for about 18 hours per day. The advantage: smaller footprint, efficient destruction, less residue. But practical deployment is still still a work in progress. Storage is its own engineering challenge. Waste that can't be discharged plastics, hazardous materials, some residuals is stored in watertight, sealed, labeled compartments. These holdouts must resist moisture, leaks, odor, mold, pests, ventilation, drainage, and isolation are key. The ship must have sufficient buffer room, because you never know when a port call will be delayed. Liquid waste lines enter this architecture too. Blackwater toilet waste and gray water showers, sinks, galley drains pass through onboard treatment systems. Some ships use membrane filtration, UV treatment, or conventional marine sanitation devices. Excess treated water may be discharged when permitted, far from shore under regulation. Bilge water, contaminated with oil, is handled via oily water separators. The cleaned water, if under allowed oil content, may be released. Oil residues go into retention tanks. Some ships attempted clandestine bypasses, so-called magic pipes, to dump contaminated bilge illegally. Those violations drove some of the strictest legal actions in maritime history. Here's a fun but alarming piece of naval lore. Decades ago, when environmental restrictions were laxer, some ships incinerated plastic on board, burning wrappers, bottles, etc. But the byproducts often were toxic. Dioxins, furans, and safety pushback led the Navy to curtail plastic burning altogether. Also worth noting, the naval journey to build these systems wasn't linear. As early as the 1970s, the Navy contracted trash compactor prototypes. By the 1990s, some compactor projects were canceled, while development shifted toward pulpers, plastics processors, and shredders. Part 5. The human engine. If a carrier's waste management system is a machine, the crew is its spark plug. Without people, even the most advanced pulpers, shredders, incinerators, and storage tanks are just expensive metal waiting lazily in the hangar deck. On ships like the USS George H.W. Bush, there is a dedicated waste management team. About 16 sailors whose job is literally to dig through tons of trash. Yes, that's their actual job. Sort it, run the machines, maintain the smell thresholds, and ensure every piece of trash follows the rulebook. They call themselves raccoons, partly in jest, partly out of respect. This crew operates deep under the decks, where humidity is a constant companion, and the air smells like yesterday's meals, plus the chemical tang of cleaning agents. But it's not just a waste team thing. It's all hands. Every sailor has to sort their own trash correctly. Paper here, plastics there, metal in its bin, hazardous in its containment. If bins are full, signal. If rags are oily, isolate them. If food is wet, bag it, or start the pulper. A small mistake, say someone forgetting to rinse a plastic container, can jam a shredder or make a whole batch of burnables unusable for incineration. The ripple effect is serious. Sanitation is not optional. Leaking trash bags in corridors, vermin like roaches and rats exploit every smudge of trash. Mold grows in dark corners, wet food decays in closed bins, and makes the air nearly unbreathable if not cleaned. So the crew runs regular walkthroughs for smell, pests, leaks. They clean and sterilize trash rooms, repair or replace faulty bins, seal lids, maintain plumbing to avoid pool-like wet spots. Safety is also a concern. A full, heavy bin carried across a deck in rough seas becomes a hazard. Sailors need to balance bulky containers through tight passageways, ladders, hatches. One spill can cascade into a slip, injury, contamination. Space constraints amplify everything. The ship's corridors are narrow, storage rooms tight, stairwells steep, openings small. The human engine must move trash from point A to point B through this maze. When a bin is full in the mess deck, a trash handler must transport it down corridors, through bulkheads, to the incinerator or compactor bay, often in shifts, sometimes in pitch darkness. It's physically demanding, sweaty, smelly, and unglamorous, but essential. Here's a fun fact. The USS George H.W. Bush has 423 commodes distributed across 130 heads, bathrooms. Yet early in her service, the fancy vacuum-based toilet system, Vacuum CHT plus marine sanitization, suffered repeated failures. On more than one occasion, large sections of the ship, or even all the heads, went offline. Sailors had to hunt for a working toilet for up to an hour. Some resorted to using showers or industrial sinks, or holding it in with health consequences. It's a reminder that even human needs systems are part of this waste logistics puzzle. Another human toll, morale. Let's be honest, trash duty is not glamorous. It's hot, smelly, often thankless. But those working in waste management aboard Bush say they take pride, getting the bins sorted correctly, seeing the plastic pucks stored neatly, knowing they're preventing environmental damage. The raccoons wear their title like a badge. When the system works, the ship is cleaner, safer, the rules are complied with, and the crew can focus on flight operations, drills, mission readiness rather than complaining about stink. Finally, coordination counts. The ship's chain of command ensures that environmental policies are enforced. Leading petty officers in waste management report to higher environmental or safety officers. Sanitation officers coordinate with engineering, supply, galley departments. Training is continuous. Inspections happen. A single misplaced oily rag can trigger a check. Improperly labeled hazardous waste can become a violation. Part 6. Innovation and the future of naval sustainability. The war against waste aboard aircraft carriers has sparked a new kind of arms race, one not fought with missiles or stealth, but with ingenuity and environmental conscience. For decades, naval vessels have been accused of being floating polluters. That perception is changing fast. What makes the IWMS so revolutionary is its automation. It minimizes manual handling, cutting down contamination risks and freeing up crew for other duties. British naval engineers joke that their waste system is smarter than some of the sailors it serves. Though the sailors tend to counter that, the machine doesn't have to eat powdered eggs for 6 months. Fun fact, the IWMS was tested under simulated battle conditions to ensure it could keep running even if parts of the ship were damaged. Because in war, nothing stops, not even the trash. The true future of naval sustainability is being forged in laboratories right now. The U.S. Navy is investing heavily in bioconversion, using microbial digesters to break down food and organic waste into methane, which can then be used to generate electricity. In essence, the ship would eat its own garbage to power itself. It sounds like science fiction, but the prototypes already exist. The U.S. Naval Research Laboratory has confirmed small-scale success in turning waste oils into jet fuel precursors. There's even talk of integrating artificial intelligence into waste systems to predict consumption patterns and optimize compaction or incineration schedules. One proposed system would monitor what sailors throw away to automatically calculate resupply needs, meaning your lunch habits could literally influence logistics for a 100,000-ton warship. History, too, has its moments of irony. During World War II, British destroyers used to dump all their trash directly into the sea until enemy submarines began tracking the trails of floating debris to locate fleets. It became an unintentional tracking signal. That's when naval waste management, quite literally, became a matter of life and death. The modern Navy never forgot that lesson. Even garbage can betray your position. These new systems don't just make carriers cleaner, they make them stealthier, safer, and symbolically more responsible stewards of the planet they patrol. The ocean is no longer seen as a dumping ground, but as a shared battleground for ecological survival. If the 20th century was about projecting power, the 21st will be about sustaining it responsibly. Future carriers may one day be closed-loop ecosystems, self-sufficient, waste-free, and energy-efficient. But until then, every melted plastic puck, every pulped banana peel, and every sailor sorting recyclables at midnight is part of that slow evolution. Part 7. The Ethics of the Deep. The ocean has an extraordinary way of keeping secrets. For centuries, it has swallowed empires, wrecks, the evidence of our carelessness without complaint. Yet even the deep has limits. And when a 100,000-ton floating city like an aircraft carrier releases waste, those limits are tested daily. Behind every sleek takeoff and heroic operation is a quieter moral war, one fought not with missiles, but with mops, filters, and incinerators. Aboard a carrier, waste management isn't just about tidiness, it's about survival. Improperly stored food waste can rot faster than morale on a Monday duty shift. Mold creeps along insulation. Insects find paradise in warm corners, and smells can turn claustrophobic corridors into chemical torture chambers. The Navy's preventive medicine manuals are filled with eerie specificity. Every deck drain, vent, and food pulper must be monitored, cleaned, and disinfected on a rotating schedule, lest one bacterium's joyride turn into a ship-wide outbreak. Fun fact, during the Vietnam War, the U.S. Navy documented that improper waste storage was responsible for more sick days than enemy action on several support vessels. Disease doesn't need propaganda, it just needs a warm bin. Then comes the air itself. When incinerators do their job well, the byproducts are manageable: water vapor, carbon dioxide, and small amounts of residue. but misfire the burn, and the ghosts of plastics rise as toxic compounds. The Environmental Protection Agency once found that burning PVC plastics can create dioxins potent enough to cause reproductive and immune disorders. That's why naval incinerators have exhaust scrubbers, high-temperature zones, and strict maintenance logs. Some sailors joke that the incinerator room is the ship's dragon. You feed it garbage, it breathes heat and smoke, and if you disrespect it, it burns your eyebrows off. But air is only half the story. Water, the very cradle of their mission, is also the most delicate frontier. A small leak from an oily bilge tank, a single improperly treated sewage release, or even a miscalibrated discharge valve can contaminate thousands of cubic meters of sea. You might think, it's the ocean, it'll dilute. But marine biologists beg to differ. If the harm isn't visible, it's easy to rationalize. The ocean forgives slowly. But sailors don't have the luxury of ignorance anymore. Modern naval training includes modules on environmental ethics, where officers are reminded that protecting the sea is part of defending their nation. Because what good is power at sea if the sea itself is dying beneath your hull? In fact, in 2022, a team of retired Navy engineers proposed a radical idea, turning processed shipboard plastic into 3D printing filament, which could then be used to print spare parts mid-deployment. A cycle where yesterday's trash becomes tomorrow's wrench. It's poetic, almost biblical, the sea returning what you give it, transformed. Maybe that's the real ethic of the deep. Not just restraint, but reciprocity. To serve the ocean, not as conquerors, but as caretakers aboard the loudest, most complex machines ever to float. Because if the deep remembers everything we throw into it, we should at least make sure it remembers us kindly.